I'm already here in the terminal and the template folder. So let's list our contents of this folder. We have a beam.ju file. So this is a trelis journal file. We have a README file. There are more details about the example in the README file, so don't hesitate to read it. We have a simulation input, a material file, and a shell script where we have all the commands we will need to run. So cut the shell file name run.sh will give us the content of this file. And the first command is a trelis command that will generate the mesh, and the second command is the command that runs the simulation. Let's look into trelis meshing of the geometry first. So let's open up trelis. If you want to look at the dimensions of the beam that are used in the simulation, look at the contents of the trelis journal file. There we have the dimension, 1.5 meters long, in y direction 0.1 meters, and in z direction 0.05. So let's apply these dimensions. We want to have a 3D geometry in trelis. So as usual, we go into the geometry mode, create new geometry, create a brick now. The dimensions were 1.5, 0.1, and 0.05. So let's click apply, and here is our geometry. So next thing we have to do is we have to mesh our geometry. So let's hop over to the mesh module, define 3D mesh properties, and for the sake of simplicity, we'll do just automatic sizing on the volume. Actually, we want to specify the approximate size, and we say 0.01 meters for the dimension. So we click on mesh, and if we want to zoom in a little bit, we have here the mesh, which is of course not ideal for this geometry. We could refine in the thickness direction only a little bit, but for a start we can stick with this very simple mesh. The last thing we need to do is define the regions we want to use for defining boundary conditions. So this is the left side of the domain where we have to create a new node set. Let's call it left. We want to select the surface, and we want to have the surface at the end here. So click apply, and here we have the node set left appearing. Again, we need another node set on top of the beam. So let's create a new one and call it L-top. Again, select the surface on top, click apply, and we have the new node set. The final thing we need is a so-called block, a new block for defining the material and the domain, the volume domain. And this should be called V for volume beam. We want to select the volume here, and we can click on it and apply. I did a little mistake for the naming of the node sets. They are not lines, so actually the index is not clear. So let's rename them and call them S left for surface on the left, and the other one will also be renamed to S top. Okay, so this is how you create the geometry in Trelis. The next step would be to export the geometry to CDB format. But since we have a finished mesh here in the template, I won't save this now, but instead I won't export it now. I don't want to save here. What I want to do is look at the run file to the respective trelis command. So here you can actually directly execute the beam.journal file that was provided with the example in the command line. So I'd simply paste this in and run it, and you will see trelis starts up and meshes in the command line. And let's see what happens by listing the files. We have a beam.trelis file and the beam.cdb file, which we will use as input for CFS, as the mesh input. Okay.